Hi, welcome to this tutorial. In this video you will learn how to analyze data using a two-way ANOVA. The data here before us is a teaching method. Three teaching methods were used to teach three groups of students, and their performance were recorded and the agenda was also recorded. So the first teaching method was labeled as 1, and the second teaching method was labeled as 2, and the third teaching method was labeled as 3. And you can see how the genders were recorded, 1 for male and 2 for female. And these are the performance of the students. Now, to import this into our SPSS, we need to open our SPSS. We don't need to copy it, rather we can just open our SPSS, then we'll go to File, go to Open, go to Data, click on Data, and this dialog box appears. So we change the file type to be Excel to recognize our Excel sheets. It has been saved as two-way ANOVA data. So we click on it, then we click on Open. Then this dialog box here appears, showing us that this is what it accepts. To read variable names from the first row, accept that. Percentages of values that determine data type, 95%, we accept that. We ignore hidden rows and columns, we accept that. So we just click on OK, and our data here is before us. Now the next thing we need to do is to tell SPSS what these figures mean. They are not real numbers, they are just for naming nominal variable. So we go to our variable view, we'll go to teaching methods, then we'll click on this value here. So 1, let's say it represents mastery learning, then 2 represent cooperative learning, then 3 represent, let's say, lecture methods. So click on OK. Then the same thing for the gender. This is also nominal variable. I will click on this none to give it a value. So 1 means male and 2 means female. Click on OK. So we have labeled it now. For performance, it's not a nominal scale, rather it is a scale. So if we go back to our data view, you can see it has successfully named mastery learning female and the performance, so on. Now to run our two-way ANOVA, we just go to Analyze, go to General Linear Model, then we go to Univariate. I then click on Univariate, the box appears. Then our teaching methods will go to the fixed factor. The gender also will go to fixed factor. The performance, which is the dependent variable, will go to this box. Then we can click on the model, ensure that there's full factorial so that we can have both our main effect and interaction effects. So just click on continue, then we go to post hoc. For post hoc, we can take for that of teaching methods. We can also look at gender in case, but may not be necessary except for teaching methods. Then if we think we have not violated any of the assumptions, especially the equality of variance, homogeneity of variance, then we can pick one of these post hoc test result, which is LSD, then continue. We don't need anything much again, so all what we need has been chosen. Then we'll just click on OK, and the result is out. Now we can see the result here. There's a warning sign. A post hoc tests are not performed for gender because there are fewer than 3 groups. Okay, this is very clear. Then this is the between subject factors. The number cooperative, there are 30. Number lecture method, there are 34. And mastery learning 32. Okay, so we'll have male and we'll have female, total 48. So okay, so this is our two-way ANOVA result here in this box, in this table. We can see this is the main effect of teaching methods on the student performance. So we just go directly to our p-value. The p-value is less than 0.05, so it means the teaching methods were effective in enhancing the student performance at different levels. So there is significant difference in the effects of the teaching methods. So now let us look at the main effect of gender. That is looking at gender difference in terms of achievement. We can see 0.24. So this is far greater than 0.05. So it means that we have to retain our null hypothesis with regards to the main effect of gender. So there is no significant main effect of gender. Then we look at the interaction effect between the teaching method and gender, which is this. We go to the p-value, you can see we have 0.247. So actually this value is far greater than 0.05, so we have to retain our null hypothesis. So the teaching method has nothing to do with the gender. So it was purely effective in across gender, irrespective of whoever the person, the student is, or gender category he or she belongs to. The teaching methods will work for both of them. However, since we have the main effect of teaching methods to be very effective, we need to look at the post hoc test result, which is this. So when we look at the post hoc test results, we can see that mastery learning and cooperative learning are equally effective because the p-value is greater than 0.05. So in this regard, we can retain the null hypothesis comparing the effectiveness of these two teaching methods. But for mastery learning and lecture method, you can see the p-value is far less than 0.05, so we can reject a null hypothesis comparing the mastery learning and lecture method. And look at the mean difference, 7.97, so which is a wide margin. So henceforth, we can say mastery learning is more effective than the lecture method. Then as well, we can also compare cooperative learning and lecture method. You can see the difference is 8.47. So, and the p-value is far less than 0.05. So we can also reject our null hypothesis comparing cooperative learning and lecture method. This means that cooperative learning method is more effective than the lecture method. So conclusively here, we can say that mastery learning and cooperative learning are equally effective and they are better than the lecture method. So thank you very much for listening, and please do appreciate our tutorial by just subscribing to our YouTube channel. You can also make some little comments about our video down in the comment section below. Don't forget to turn on the notification bell so that once we upload new video, you get notified right away.